Okay, our second part for today is acids. Okay, we're going to learn to write the formula of common acids. Uh, if you go on into chemistry in college, stuff like that, you will find out there are multiple theories on acids. We are going to deal with the kind of the most common theory, the one that people think of when we think of acids. All right. If you've heard of amino acids, like in your body in organic stuff, that's a little bit different than this. Okay. All right. So we won't be dealing with amino acids as far as that goes. All right. So first of all, for us, acids are ionic compounds that all start with the hydrogen H plus ion. All right. They all start with H plus. Now, another side note, technically, for them to be acids, they have to be dissolved in water. If they're not dissolved in water, they're technically not an acid, and we name them slightly differently. We are not going to make that distinction now, but if you take the college class, we will, and it's really not that big a deal. It's not that big a deal. All right? Once you know this, it's very simple to do the other. Okay? Binary acids. Okay? Just like we've done with binary, there's two elements, except the first element's always going to be hydrogen, and then a nonmetal. All right? Acids will contain hydrogen and a nonmetal, or a polyatomic ion. All right? We still have to balance the charges, but it's kind of simple because what's the charge of hydrogen? No, it has a charge. Plus one. All right. It's plus one. So whatever the charge of the other one is, that's how many hydrogens you're going to have. You will never have to add multiple. You will never have to add multiple of the negative ion. Okay. And again, you don't have to write this down. I already mentioned it. Technically, to be acid, it has to be ionized in an aqueous water solution. But for us, we're going to treat everything that starts with hydrogen as if it's an acid. Somebody might ask, what about water? Somebody might ask that.
What about water?
Water is technically kind of a unique substance. It can act as both an acid and a base. So technically, it is an acid, but it's also a base. All right. So anyway, we will not be naming water using the acid method, just so you know. I guess if we did, it would be hydroxylic acid, but we're not going to worry about that. All right. I see pencils moving, so I will wait. All right. You guys ready? Okay. So for binary acids, again, it's just going to be hydrogen and one other element, right? Binary acids are always named like this. They will always start with the prefix hydro. The prefix hydro tells me it's binary, okay? Then they use the base name for the second element, and then acid. They will end with the name acid. All right. For example, hydrochloric acid. All right. The hydro in front is just telling me it's binary. It's just going to be hydrogen, and then what element's it going to be with? In this case, what element is chlor the base name for? Chlorine. Very good. All right. So hydrochloric acid is going to be hydrogen and chlorine. They're both one, so it's just HCl. Is that hard? After doing everything we've done, kind of easy, isn't it? Okay, I think I have another example. Hydrosulfuric acid. All right, hydrosulfuric acid. So what's it going to start with? What element does it start with? Hydrogen. And it's plus one, right? And then sulfuric is going to be which element? Sulfur. What's the charge of sulfur from your periodic table? negative 2. So how many hydrogens do I need? Now you're lost? Okay. We got to come out to 0 again, right? Does it come out to 0 right now? Yeah, you just got to have 2 hydrogen. So for these, kind of to make it simple, whatever the charge is here is going to be how many hydrogens you're going to need. It's just that simple. All right? You will never have to have more than one of the negative ion on the acids. All right? Are you with me? All right? Hey, let's see if I typed it out. Oh, look, I did. So H2S. Hydrosulfuric acid. Binary acids very hard? No. I see a couple pencils still moving, so I'll give it a second. All right. Okay, so after we did binary in our other stuff, we went to ternary, right? Well, ternary acids, if you remember, ternary ionic compounds contained what? What's on those pink sheets? Do you remember? Polyatomic ions. So guess what ternary acids are going to contain? A polyatomic ion. All right? Ternary acids will contain hydrogen, still hydrogen because that's what makes it an acid. But they will not use the prefix hydro. That's how we know the difference. If it says hydro, we know it's binary. If it doesn't have hydro on it, but it's an acid, then we know it still starts with hydrogen because it's an acid. All acids start with hydrogen, okay? But this is going to have a polyatomic ion, all right? If the suffix on the acid name is ic, then it combines with the 8 ion from our pink sheet. Okay? So if we keep going, and if the suffix is us acid, then it's combined with the ite ion. All right? So get those rules down. We're going to practice with it here in a second, but I will make sure you have all the rules down. I think that's all on this slide. Yeah, it is. I can slide it all the way up. All right. You guys got it? Still writing? Okay. Still writing. All right. You're fine. Okay, you guys ready to do some examples? 1 second. Okay, thanks. If I get too rushy, you just tell me. I don't know if rushy is a word. Okay, are we good? Okay, I don't see any pencils moving, so. All right, so let's do this example. Nitric acid, okay? So what element does it start with? No, hydrogen. Always starts with hydrogen if it's an acid. So H with a +1. Now, nitric is going to go, it goes to which ion? It goes to nitrate. So we find nitrate. Nitrate is NO3 with a -1. All right. And so nitric acid will be HNO3. That's a pretty strong acid. It's used in mining operations, actually, to dissolve silver and sometimes copper out of the ore. You'll actually eat it out. Okay. Oh, yeah. Are you with me? Yes. Okay. All right. Oh, look, it's just like I just said. H is +1, nitrate's NO3 with a -1, so HNO3. All right. Let's look at this one. Sulfurous acid. So what element's it going to start with? Hydrogen, because it's an acid. All acids start with hydrogen. Us is going to be what? Ite. Us goes to ite. Now, it's a little bit different because of the way they name it. It's not sulfurite, it's just sulfite. But then you do put the back in there for the other stuff. It's just weird. Sometimes they just do things and they say, well, it sounds better. All right. Sulfite is SO3 with a -2. So how many hydrogens am I going to need? 2. So this will be H2SO3. Is that too bad? No. After we've done the other stuff, it kind of goes back to being a little easier. Does that make sense? Yeah. All right, especially the prefix method. Oh my gosh. You just write what it tells you. All right. Hey guys, I'm going to give you your assignment. This ends the video for today if you're at home. And let me stop it.